Hey, and we're live. And my video is frozen, it would seem. Can everybody hear me all right? Yeah. Let me try turning my video off and on again. Yeah, having a little bit of trouble here. Excuse me for one second, folks. I will put the music back on and be right back. One sec. We got video this time. Hi, everybody. Thank you so much for putting up with me, and thank you so much for joining us today for the April Suborbital Community Meetup. My name's Ramon. I'm super excited to be here and, introduce our wonderful speakers today and get things rolling and keep things running, hopefully more smoothly than that beginning. So let's hop right in. We've got three of our folks coming in today. We got Laura coming in, talking to us about updates to the suborbital docs. We've got Gabor coming on to talk about the externs program. And we've got Flaki coming on to give us an Atmo architecture overview that involves reviewing the, quote, building blocks. I don't know about y'all, but I'm super excited to bring folks on today and chat and hear and learn. So without further waffling from me, I'm going to bring on our first guest, which is Laura. So here we go. Hey, Laura. You are currently muted. Sorry, if you could please unmute yourself.
Hello.
Hey, how's it going?
It's good. It's good. How are you?
I'm good too. Thank you. Good too.
Good. All right.
Yeah, super excited to hear about what's new in the docs. And I'm gonna put up a nice little banner here showing who you are.
Thank you. Can you see my screen?
Not yet, because I haven't put it up yet. Give me one second. Here we go.
Alrighty. Not the docs have been pretty stable this month. Not too many changes here, but one significant change that we are pretty excited about is we now have the ability to search our docs. So we can search for, say, Atmo, and we've got these sort of pre-populated. Maybe these are what you're looking for, and then if they're not what you're looking for, then we can see all the results. Works just like you'd want it to. So that's super nice. We have also had several blog posts in the last few weeks, really 2 weeks maybe. We have 3 new blog posts up. There will be at least 2 more this week that I know of. So be sure to check those out. And we've also had several streams. These do get recorded and uploaded to, well, they are, as you can see, live streamed on YouTube and also recorded. And so you can always catch up on these later if you're interested. So if you have not already subscribed to our YouTube channel, be sure to do that. And that's all from me. Thanks, Ramon.
Sure thing, Laura. Thank you so much for that. Folks, as always, want to give you all a chance to ask any questions that you might have in the chat. I for one, am super excited about what we've got coming up here with the dogs, and I think it's and we got a lot of work going into it, and it's a lot of appreciation as well. So thank you, Laura, for helping us get that up and running.
Sure thing. Thanks, Ramon.
Sure thing. All right, then. Well, if there are no questions, then I'll move on to our next speaker. I'll see you later, Laura. So next up, let me take away this banner. There we go. Next up, we've got Gabor joining us. So here we go, bringing you live. Hey, Gabor.
Hello. Good morning, afternoon. Your choice of time where you're at.
Yes, thank you so much for coming on today to tell us about the externs program.
Yeah. So it's a program that GitHub has in India, and we've been fortunate to have to host 2 students from 2 institutions. I think they're in different institutions. Let me just very quickly double check. Yes, they are from 2 different institutions according to their GitHub profile pages. And we've been working with them and helping them contribute to one of our open source repositories while they spend their time with us. And it's been absolutely fantastic.
Amazing. And how would you say the experience has been moving forward and going with working in the future with the program?
Yeah, so I think there are many different findings that that are useful for both me personally and also for the company. So for me personally, I am very new to sort of taking care of other people. I've never really been in a management at all where I have you have 4 people to report to you, and then now you need to your job goes from being a coder or a developer to being the unblocker of everyone else. So that was an interesting change when it comes to working with them. The other one was because they are in standard India time zone, IST, which is GMT plus 5.5 hours. And I'm in GMT plus 1 because British Standard Time. I'm in the UK, folks. But most of the company is in East Coast, which is GMT minus 5. So it's easier to bridge the GMT plus 1 and plus 5.5 gap than the minus 5 and plus 5.5, which is 10.5 hours. So that's also an interesting um, that's also an interesting sort of consideration that we, both I personally and we as a company, need to make, is that if we have people who need a bit more contact time with any of the people currently working at Suborbital, we need to be able to sort of move around either personal time or just select the people who will be interacting with them in such a way that it isn't super distracting for like personal time. Um,
Yeah.
yeah, and also from a company point of view, it's been very interesting to see how people who don't really know much about our products and don't have the existing domain knowledge um, of how everything works, how they approach working on a piece of code. What are the things that they need to find out that needs to happen so that they understand it well enough so that they can actually contribute in a way um, that brings them the feeling of satisfaction that they've actually contributed in a meaningful way, and a layer of kind of like a usefulness, which is very utilitarian, but to us.
Yeah. Yeah, of course, because I guess one big experience we got, as you said, for us, is helping us improve things like our onboarding processes to the code, to the different code bases, as well as being able to work on these projects, uh, get up and running as quickly as possible.
Yeah.
Absolutely. No, that's great. So I'd love to ask, do you have any how do you feel about being able to do something like this to help motivate folks to make contributions to projects? I hope I'm not putting
So
you on the spot there.
no, no. I mean, yes, kind of, but I worked in this industry long enough for me to be able to sort of take it in strides. Um, you know how those how some of the like funny news segments have this like person, and then the banner just says their name, and then it says former child. It's like everyone's been a former child, kind of.
Hmm.
So as a former person who contributed to open source, because I tend not to do that too much these days, due
Okay.
to like shifting um, focus and whatnot. I know that one of the like there are two big things where a project and the community behind the project can influence whether someone is going to end up contributing to something or not. One of them is the community itself, whether they are equipped, able, and willing to uh, accommodate people who are new to the code base, or whether they have this sort of attitude of read the manual and then come back and then go check it out, and like, I'm not wasting my time if you haven't done all of these things. So like one of those approaches is going to encourage people to stay, and one of them is going to strongly push them towards other ways of spending their time.
Well said.
Um, the other way is um, actually the code base itself and the documentation. And for example, if we have issues, do we have a clear description of what is it exactly that we're looking for in this? What is the problem statement? Do we have acceptance criteria? Is it something that they can check themselves by running code and then seeing an output? And do we have the, if you see this output, you have been successful. If you see this other output, these are the possible ways that that you might need to adjust your code base. And then whether working with the code base itself is easy or not. Like if you have to install 472 different libraries and command line things, it's probably not going to be something that open source contributors would want to tackle. They could, but would they want to?
Yeah, it's a barrier to entry in a way. Is that
Yeah.
accurate?
Yeah.
Yeah. Cool. Thank you. That's been super helpful. And thank you very much for giving us that update, Gabor. Did I miss something there that you might have wanted to mention?
I'm not sure. I think. I mean, I'm also kind of curious whether the community has any questions about
Oh yes, of course.
this.
Yeah.
But looking at the channel so far, no.
I mean, folks, as said, at any time, we're keeping an eye on the YouTube chat as well. So if you want to pop a question in there, I'd even be able to highlight it and ask it. If not, we can keep them coming, and we'll keep the content coming as well. So don't worry, folks. There's plenty of time to ask questions.
Yeah.
Nice.
All right.
Cool. Well, Gabor, thank you so much. This was really interesting to get an update on it. And for me, something like, improving the maintainability of open source projects is something, not the maintainability, sorry, the first time contribution ability of open source projects is really critical for me. So it's really interesting to hear about. So thank you very much for coming on.
It was my pleasure. Thanks for having me.
Yeah, sure thing. And see you around. Thanks a lot, Gabor.
Yeah, thank you. Bye.
Cool. Cool. We are making record time through. We've got one more presentation or chat for you today. We're gonna have Flocky on, who's gonna update us on. Give me 1 second, folks, to remove this banner. Thank you. Yeah, we're gonna have Flocky on, who's gonna be. Oh, actually, we've got a question. Gabor, would you, if you don't mind terribly, could I bring you back on? Yes, I see a thumbs up that you all can't see, folks. But yes, I'm going to bring Gabor back on.
Yeah.
So I'm going to highlight a question here from Naya, who's asking, Naya. So I'm going to put that into the chat. I'm going to remove these slides. There we go. How can folks interested in the externship program apply for the next round? Which is a great question.
Yes. So the externship program is maintained by GitHub India. GitHub India has a specific website for their externship programs. Yeah, currently, sadly, that website has some certificate issues. But the way that works is that you, as a company, need to apply to be a partner organization. Essentially says, hey, I am a company of X doing something, and I am able to take on, I don't know, 2, 3, 4 students in this program. And then similarly, the students would apply to this externship program. And then I don't actually know what happens inside GitHub, but I guess there's a selection program selection process. There we go. And then GitHub says to the partner organizations, hey, we have this list of candidates who we think might be good for you. And then I think potentially the partner organization gets to decide who to take on. But that would be probably a question that Connor might be able to answer a lot better than I can. But essentially, as a student in India, once GitHub fixes the certificate, go to externship.github.in and then read documentations there, and then they will be able to guide you through the application process.
Nope, I'm muted. There we go. Cool. Thank you. So we got a couple more questions coming in. One is from Laura, who's asking, I think there's a question more for Connor, maybe, but might we partner with any other orgs in more countries?
Yeah, so Connor answered that in the chat, and he said, yep, we do interviews, and the partner orgs make offers to, wait, no, that's in relation to the externships.
Yeah.
Okay, yeah. I mean, I guess, so as far as I know, there's nothing stopping us, Suborbital, for partnering with other organizations, whether it's something that we only do via the GitHub extension program or some other programs, I do not know, and I do not have the proper powers to make that decision.
Yeah, I understand. Thanks a lot, Gabor. No, but oh yeah, there's similar orgs like Outreachy. Outreach is awesome. Yeah, no, wonderful. Thank you very much. Cool. I will let you go, Gabor. Thanks a lot, and see you
Um,
soon.
there's
Oh,
there's one more comment from Dino Pink,
oh,
and he says it's probably more geared towards students wanting to apply to Suborbital's externship program. And again, that would be a question for leadership to weigh in on. I think what we're going to do is take away, it's going to sound super corporate and super buzzwordy, but we're going to take all of the findings from our current experience, kind of assess what has happened, what went well, what we can improve upon, come up with a plan, see how that fits into our short and longer term plans, and then make a decision there. So I think the best answer is that actually Connor says that he fully expects that we'll do more programs like this. Yes,
wonderful.
I don't know how or when, and I don't think that we can give a definite answer to either of those questions at this moment.
Wonderful. Thank you very much.
Mhm.
Got a comment here from Critic Modi as well. The GSOC, Google Summer of Code, open for students and professionals around the world above 18 to work at open source organizations. And yeah, Flaky makes a very good point. You definitely don't want to just say blindly yes to everything without being able to see it through and support the externs and interns. So totally, that's a very important point.
Yeah.
Cool. Yeah. Thanks a lot, Gabor.
Mhm.
And thanks for
My
coming
pleasure.
back on. See you later.
Bye.
All right, folks. Let's thank you all for being so flexible with me. I will now bring on Flaky. Hey, Flaky.
Hello, hello. Can you hear me all right?
I can hear you fine, and you're going to be talking
All
to me
right.
about Atmo and reviewing the building blocks. I'm very excited for this, and I see you're sharing your screen. I guess you want me to put that up,
Yeah,
yeah?
you can put that up and we can get started.
Sounds good. I'll be back here. See see you on the other side.
All right. Sweet. Yeah, hope that it should be all right. So my name is Flaki, which is the short version of Istvan Smorzhansky. I work with Ramon and like a couple others, Laura, on the DevRel team here in Suborbital. And recently, I've been kind of looking into like what sort of like information, like Connor has been talking about, like Connor was talking about like SAT, which is like an upcoming module to the suborbital ecosystem, and we have talked about like various parts of the suborbital ecosystem before, and I was like thinking, okay, what is the thing that we haven't really mentioned yet before? And we here at Suborbital, we kind of happy to talk about how like Suborbital like has this like it's built on this like fully open source ecosystem, and like Atmo, are one of our flagship open source products, is one of these things that is like itself built on like multiple like open source components that we call building blocks. And like we rarely really talk about like how this whole ecosystem of components like fit together. So I figure, that might be an interesting or useful thing to kind of have a look at. And instead of like focusing on how to write applications for Atmo or like the suborbital ecosystem, and how to run WebAssembly on the edge, or like on the in the cloud, like maybe kind of have a like peek under the hood and like see kind of how like the modules fit together, and like what could you do with these building blocks, besides or even outside of Atmo, like could you be potentially using them for your own code or your own resources. I want to preface this like with something like there Atmo and like the suborbital ecosystem supports a lot of different languages. You can compile various languages into WebAssembly and run them in like Atmos runtime. At, the suborbital itself, or like the suborbital components themselves, are largely, or the majority of them are actually written in Go, like Golang. So we are going to be looking into like some of the repositories that you're going to be finding on the suborbital organization. And so just to preface this, that like most of these repositories are actually Go code. It was been a really interesting experience, in particular for myself, for somebody who has actually not really been acquainted with the Go ecosystem and like Go programming language. Kind of like my first time of like really like getting like up and close with like programs written in Go was when I actually started here as Suborbital before the end of the year. So it has been really interesting to kind of catch up on like Go and like kind of start exploring the code base myself. I have some background in C++, C, mostly from like Arduino projects. Like as of late, like I used to study a little bit of like on C++, and like various other like programming languages from JavaScript to a bunch of others. But like as of really like as of late, like a bit of Rust. I'm mostly being like on the other side of Rust, where I've been organizing community things. I haven't really had the chance to actually code a whole lot of Rust, but like I had some exposure to lower level languages. So like this is my experience, but I actually found Go really readable in particular. And this wasn't the first time I've been, kind of forced into reading Go code, but like just kind of syntax and like the code itself was kind of I would almost say straightforward to me. So if you do have like some underlying like experience, even if you haven't actually worked with Go, I implore you to kind of have a look at some better documented and better like more modern code bases in Go. Like might be a good example or like a good way to kind of find your way inside into the language. I'm particularly myself, I actually learn better like a language when I can read code versus like read a book or like I don't know, watch a tutorial. So that actually helps me a lot in like kind of grokking like what the language is really about. So that was a really interesting experience, like kind of like learning Go through like kind of diving into our code bases. Particularly because like we have been spending a lot of effort in documenting like these exact code bases, and like a lot of the very first part of the documentation, you only can do two things. Like you can either talk to the people who wrote the code or like read the code yourself. Like when you're writing the documentation for that piece of code, especially like we had like some code that like we hadn't really had documented from like the early days of the company. Like kind of catching up on that is really like something that you are going to be reading a lot of code. And so but that was a really interesting experience, like kind of extracting this information out of the code base and like kind of grokking in the meantime, like how the whole system is connected together. So as I was mentioning, like we have Atmo, which is basically like one of the flagships of the ecosystem. This is the server that you can use to deploy your own applications using WebAssembly. If you have been looking into our documentation or even tried Atmo yourself, you will know that the Atmo focuses on bringing like this like primarily services, like service applications, like API services and similar to the cloud, and like making it easy to kind of create applications that have like multiple, like tie together multiple endpoints and like let you without having to worry too much about tying your app into things like writing boilerplate code, like connecting to a database or something like that. Atmo kind of takes care of that, while also providing you with an opportunity to like kind of choose your own language or choose your own favorite tool to use to write these applications. And like Connor actually has a blog post coming up, kind of dives deeper into what sort of applications you should be able to look into using Atmo for, or like what are like the kind of strong parts of like Atmo's design that like kind of help you design your own applications. If you actually got into like the getting started or tried Atmo yourself, or even like SCN or other product, you have probably came across the Subo tool. The Subo tool itself is actually kind of what ties together the entire like suborbital ecosystem. This is like a you could say it's like the user interface to the suborbital ecosystem. Be that again our Atmo product or like the suborbital compute product, this is the command line interface that you can install to your computer and use um, to either spin up a new instance of the suborbital, like some of the suborbital, be that SAT or Atmo, like use some of these tools, spin off a new service, or like just develop some applications, like compile source code into like deployable runnables and deployable bundles. So this is like, you know, we kind of call it like the one-stop shop for like this suborbital ecosystem. And this CLI tool itself has also been written in Go. If we harken back to, what was it, two or 3 months ago, we actually had one of the engineers, Naya, give like kind of an overview about like implementing a new command line feature into the Subo tool. So you can go back and check that out in like one of the previous community meetups. Somebody can probably find the link to that to drop that in the chat. But also this was like the externs have been working on like the Suborbital CLI tool themselves as well. Like we had like some, how do you call these, like the life improving like features landed end-to-end, like especially developer experience improving features landed in the Suborbital tool thanks to our externs contributions. So you will be seeing like a bunch of things here, but like basically like we built this tool for you to be able to access some of the powerful offerings of the Suborbital ecosystem without like needing to leave your terminal or having to install like every like extensively, you know, just installing multiple like command line tools to like compile, for example, Rust or Go code to WebAssembly, kind of to make this build process like a lot easier. We built this one tool that will let you like basically spin up an Atmos server. So, you know, imagine you got your Suborbital tool, you start writing your, we have this concepts that describes like some of the concepts that I'll be talking about. And we're talking about runnables, which are like these WebAssembly compiled modules that we are going to be using inside Atmo. And also, you tie these together in a directive file. In the directive file, you list various handlers, which are basically endpoints that you want your server to respond to. And these endpoints will then like execute some of these functions in order, or like, you know, according to the various rules as they define, to kind of service like a web request. So like this is how you like get to like having a, you know, like a runnable an executable, or like a ready to an app or application that is ready to go, right? And so you do subo build or like subo dev to develop your application, like edit these like files, and eventually you have a working application. But what happens after this? Like what happens inside or under the hood of like the Atmo Atmos server is something that I wanted to kind of have a more a deeper look at, and this is where our building blocks come to you. So if I click over here into the building blocks, you will see that we have like 3 building blocks in the suborbital ecosystem: reactor, vector, and grav. This is roughly, I would say, like almost like a uh, 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 like a order of importance, or an order of how likely you are to be wanting to know about these things in the first place. And probably many of you have already heard about reactor, which is like the heart and soul of like our WebAssembly executing like servers. This is the module that is actually responsible for executing WebAssembly files and then like handling the execution of like WebAssembly. On the other hand, Vector and Grav are also like important tools for like the Atmo server itself. Vector handles like kind of the ingress. So like as you like I mentioned the handlers that you set up, like Vector is the component that is the piece that handles the serving web requests and like forwarding like the information received through like REST APIs or like web requests into like Atmos like executor engine, which handles the execution of these. So if we actually go back to where is that? The directive, but basically Vector is the one that takes care of the handlers that you see here. So you can define the handlers, the endpoints, the various HTTP details of like what a request entails when we want to receive this. And then these requests are then handed over to like Reactor for execution. There is like a couple details that I'm going to highlight here, but like that's like the basic idea is like Vector handles these incoming requests and make sure that you are able to like your server is able to handle these like high performance. There's a third component which is probably like the most obscure, or like the most probably the most the least frequently or like the most heard about, or you would come up across it like probably it's Grav. And like Grav is the how no matter how obscure it is, or like it really kind of like blends into the background of like how Atmo works, but it's just as essential. And especially if you've been around for Connor's like talk about like our upcoming set platform, upcoming set ecosystem, like that ecosystem builds really heavily on Grav in particular, to be able to create this mesh of inter operating modules and collaborating modules at the background, and like to be able to scale your WebAssembly applications to like a larger or a larger like across larger like constellations, or like larger combined components. So how this actually like fits together is something that we are working on a better way to describe inside the documentation itself. But we have some information about some of these components and how they fit together in Atmo that I wanted to kind of just uh, just lightly touch on. And like basically the whole idea here is that we are going, your requests basically arrive in, I wonder if that's loading. That's not something I want to do. Oh, that's the thing I want to, yeah, there we go. So, oh, wow, that's not sure that's exactly what I wanted. Maybe a highlighter. Yeah, that's much better. So vector server is basically what receives a request. Like we have seen these like in the handlers, not here, but the directive. So you define a handler, and somebody makes a request to this hello endpoint. Vector is the first component that receives this handler and collects the information that's received in the HTTP request and forwards it to a coordinator that takes care of based on the file that you described, the application bundled that you deployed. Vector can know that, if that's an actually existing endpoint, it hands it over to the coordinator, who is then responsible for reading the instructions that you left in the directive. This is mostly about the steps, or we have other interesting things that not necessarily related to this, but the coordinator basically coordinates the execution of the steps that later here the execution will entail. So the coordinator actually also takes care of using Reactor to actually create an engine to execute the various WebAssembly functions that a handler needs to run. So here you actually see that we have a group of functions that need to be executed. In these cases, you have supplied in your runnable in your bundle runnables that that basically either modify the URL, that there is a hello world RS runnable. These are all WebAssembly files that the Subo tool has built and compiled into this bundle that was deployed in your Atmos server. So the WebAssembly runtime now needs to be able to get these files and execute the code contained in these runnable files based on the context that the request contains. So the request then flows through the coordinator. The coordinator takes care of creating Reactor instances that will take care of executing this code that's contained in the bundle. What happens? You could ask if you actually need to use some of the runnable APIs. You might have, if you have used Atmel before, you know that while you can just create pure WebAssembly functions, that would be not very flexible in terms of what you could achieve. But Reactor itself actually, so this is a component. This component in Atmo actually provides extra APIs that provide you various other kind of hook points into system APIs or resources in the Atmo server that you could use. One great example is the HTTP client, or for example, the SQL databases. This means that the Atmos server itself and can make it possible for WebAssembly modules to make HTTP requests, or even to use a SQL database. Basically, the setup of a SQL database happens in the directive file that we described earlier. And then you create the queries that you might want to be using in separate declarative files. But at the end of the day, you can invoke these queries from your application. But for that to be possible, first of all, your reactor module needs to be aware of these APIs, which it is, because the reactor module is the one that contains these APIs. And like, if you actually tuned in earlier, Ramon and Connor had a stream about evaluating running Ruby inside WebAssembly. Ruby recently has been doing great work in trying to target the WebAssembly ecosystem. And Ramon and Connor in the live stream just an hour ago looked into like what would it take to implement Ruby support into like runnables into like a reactor system, so you could be able to use Ruby and the Reactor framework. So if you're interested, kind of going more detail into like how this whole thing happens in Reactor, you could just go and watch that stream. But like the details here is like Reactor actually taps into services provided to it by the coordinator and like Atmo, and where Atmo provides it, like for example, a database connection to be able to run these SQL queries, or for example, like HTTP services that lets it do HTTP requests. So all these runnable APIs are actually like services, or like for example, you want to log something out of like the WebAssembly module using the log runnable API, then you can access Atmos structural logging service throughout like this like WebAssembly runtimes. So that's like Reactor is like a key component of like executing like WebAssembly functions and suborbital ecosystem functions. You might raise a question: what's the point of Grav then? And like Grav is what kind of creates the makes the communication between the components of like suborbitals like systems like really easy. Grav is an extensible kind of message passing like ecosystem, or like a message passing like module. The interesting part is like the underlying protocol over which Graph communicates can be extended. You can read a bunch more about this like in the docs, but I think like we have at least I think WebSockets is definitely one of them. I think maybe gRPC, like somebody can from the DevRel team can correct me, but like the team has actually implemented multiple message passing like kind of backends for the Grav system, which doesn't really, it's not that interesting when you're running a single server on a single machine like an Admiral machine. But like for example, our SCM product, or like running multiple SAT services like distributed like in kind of like an edge situation, Grav would become like absolutely like essential to be able to kind of connect like the various like this distinct components, like distinct like function execution engines and like coordinators of this suborbital ecosystem across like machine boundaries and like large distances. So this is where like probably this is also one of the reasons that that it kind of remains a bit more obscure, a bit less talked about, is because it kind of melds into the background, like providing this kind of infrastructure quietly humming away in the background, and like also more interesting in like there are more distributed aspirations with SAT and like the rest of the ecosystem. But then it is then when like Grav becomes like kind of essential to kind of connecting the pieces of this ecosystem over like large distances. And I can tell you that like we are preparing some really cool things, like especially like when we already have like a set demo or like a set like kind of preview that you can play with, but like we have a lot more updates coming up on like around set and around our distributed like kind of interconnected meshed server like side or cloud WebAssembly offerings. So keep an eye out for that. Yeah, so that was pretty much, and yeah, like the super repo, as I said, like that kind of ties all of the ecosystem together by making it easier for you to like build applications like bundle, WebAssembly modules, build like WebAssembly target, like runnables, and like kind of take care of like all these like heavy lifting without having to spend most of your day installing tooling and for the suborbital ecosystem. So this is kind of like an overview of like how like all of these like components that you can find on our documentation page and the building blocks and everything else kind of fits together. And like we're really proud ourselves. Like I mostly talked about Atmo. We call it like our flagship open source offering. But like really what you see here and really what you see in Atmo and all these building blocks are what power our compute product. Like compute is the closed source product that we develop and like that we make available for companies to kind of integrate into their systems. But like the really interesting and the really important part that we proud ourselves of saying is that compute is actually just an extension over like Atmo and like maybe later set and like the rest of the ecosystem. So it's not like we are building open source tools on the side while also building a product. Like it's essential, like these are like essential tools that our own products are built upon, and we're using the exact same tools that if you decided to like build like products around Atmo or around some of these building blocks, you would be using the same exact like components that we are using to provide our services. So thank you. So that was pretty much like the overview. I hope you kind of enjoyed, and I hope I kind of been able to reveal a couple details about like how the underlying ecosystem works. If you never coded in Go, like you check out like Subo or like the Atmo repository. Maybe that will like give you like a kind of whet your appetite for the language. We do have uh, like a couple good first issues in some of these repositories. So if you kind of wanted to get your hands dirty and learn a new language, or like wanted to contribute to an open source software, if you're an existing like Go developer, like that might be a good way to kind of jump into. But also like if you're actually like a seasoned like Go developer and like you're building some web tooling or web related tooling, some of these components you might actually find useful, like maybe not like necessarily like the large parts like Subo or Atmo, but like maybe Reactor itself could actually be a useful thing if you wanted to or decided to integrate like a sort of like WebAssembly runtime into a Go application. So do check them out, and like thank you very much for listening. If you have questions, feel free to drop them in the chat, and I'm super happy to answer. Also, if there is some questions, like if you have more deeper questions, we have a couple actual engineers on the dev team around who might actually have a bit more deeper knowledge if you manage to gotcha me with a question. So there's a time when you should ask those. But otherwise, thank you very much for listening.
Awesome. Thank you, Flaky. That's been a fascinating look into, and like every time I get another tour of like the inner workings of this ecosystem, I feel like I understand them a little bit better. So this has been really helpful. Thank you. And I think, and I love your message of like, incentivizing folks to contribute and like, like you said, get their hands dirty, give it a try. And I actually started diving into the Subo code base myself recently, and it's been good fun. Like I have little to no Go experience, but it's, if it's a transferable skill between languages, and it's totally doable.
Absolutely. Yeah, it was really interesting. Like I said, like this is how I learn languages in general. You get immersed in them, and like that was absolutely an ideal way for me to go about this.
Yeah, totally. So, folks, if you've got any questions, please do drop them in. If you've got any, issues that you find interesting, like, feel free to take a look at them. If you want some help, feel free to, you know, ask for help and see how we can make that contributing experience easier for you. And yeah, no, this was great. Thank you, Flaky. So if there's no, oh.
Sorry, just posted
All of
some
it.
good first issues in there.
Fantastic. Yeah. No,
Yeah,
fantastic.
I think people will always find us on the Discord, so feel free to drop by
Exactly.
anytime.
In fact, if you are watching on YouTube or watching this suborbital.dev. Sorry, if you're watching us later on and you want to join the Discord,
Oh yeah.
feel free to check out our Discord. Here, I'll put up a link here on YouTube. I wanted to do this in general as well. So that's chat.suborbital.dev.
Mhm.
Yeah, join in and let's join the community, join the conversation, and honestly, just come ask for help, and we'll figure it out together.
Yeah, absolutely. Yeah, thank you everybody for listening. Thank you for joining the meetup, and see you next year, next month,
Next month,
next
yeah.
time.
Thanks a lot, Blackie.
And
Okay,
also next year, like you
I,
never know.
I would assume so.
Mm.
Cool. No,
All
then
right.
I'll say goodbye, Flaky. Thank you very much.
Thank you. Goodbye.
And yeah, that wraps up April's Suborbital Community Meetup. Thank you all very much for watching. If you're watching this after recording, thank you very much as well. And yeah, keep on contributing, keep on learning, and keep on chatting with us. And yeah, let's keep it going. Thanks a lot, folks, and see you in May. Have a good one.